Well, the truth is that this little guy is having ear surgery today. So I'm going to stay home with him and make sure he's doing good. They're just going to put in some tubes in his ear. So I want to keep going with the lab today so you guys don't fall behind, and that way you know exactly what's expected when you finish up this lab. So your job today is going to be to look at the relationship between weight and mass and really see why there is a difference in these two properties. We defined them on the previous slide, and you can look back and see the difference there. But you're going to get some real numbers to back this up, like how are they different, and mathematically, what is the difference? So when we're looking for a relationship between two different variables in physics, we kind of follow the same pattern. The first is we're going to take a really wide range of data. And the way you want to think about this is if I'm looking for mass values and weight values, I want to start from the very smallest that I can measure with the setup that I have to the very biggest that I can measure. It's not always possible to max out and get the largest numbers possible, but with the equipment that we have, you're going to try to shoot for the biggest range that you can. The second thing is once you're getting that data, and this doesn't have to be afterwards, it's kind of along the way, you organize that data that you're collecting in a data table so it shows a really clear comparison of weight values and mass values for these different data points that you collect. Once you're done with the data table, the next logical step is instead of just staring at that data, trying to get ideas from it, we want to graph it. Graphs can show us a lot simpler explanations to what's going on with data, and we can do a lot of things with a graph to analyze and follow up to search for trends. So as far as material to use to get this data collected, we want something that's really easy to make large and small quantities of. We want it readily available, and it's got to be safe to work with. Often in physics labs we could get data a number of different ways, but we're going to try to search for something that we can pull off in our lab class. So the choice that makes the most sense is none other than water. Water is super easy to use, and we can just get it from the sinks on the side, and there's a really nice property of water that we're going to take advantage of to get one of our data points, and we'll talk about that next. So like all materials, water has a certain density, and density of water actually is a very special property because when you take the mass divided by volume for water, the ratio always equals out to 1, meaning there's 1 gram of mass for every 1 milliliter of water. So this makes it really nice to work with because what we can do is we can just take a look at how much volume we have, something that's really easy to collect by pouring water into a graduated cylinder and then just seeing how many milliliters are in there. We indirectly then know how many grams of mass are in there because the number of milliliters would have to equal the number of grams of mass since the density of the water equals out to 1. Alright, so we're good on getting the mass. All we're going to have to do is just know how much volume we put in, and then that will also be the amount of mass in grams that we're adding to our bucket. Well, the next piece of data then we need to get is the weight, and the weight is measured in these spring scales. The spring scales can tell us how much force is pulling on them, and that's due to that force of gravity. So when we're reading these spring scales, we want to pay attention to the metric units of newtons and not the British unit of pounds. And if you can see the needle on this spring scale, it's pointing somewhere between 6 and 6.5. And the reason I'm getting those values, if I break up each of those hash marks, each little tick is about 0.5 of a newton. So somewhere between 6 and 6.5, we're going to have to give it our best estimation. And it looks about smack dab in the middle. So my best estimate would be that this is around 6.25 newtons. Please try to estimate as nearest you can. Don't just round it to whatever the nearest whole number is. Try to be as precise as you can when you estimate. Now that we know how we're going to get mass and force values from the instruments that we're using, I want us to start thinking about good data collections in physics. And it really comes down to range, accuracy, and precision. When we talk about range, you really want to shoot for the full range of the instrument that you're working with. Like on the spring scale, I can go from 0 newtons all the way up to about 18 newtons. So I'm going to try to spread out my data points within that range. I can't really, with the equipment I have, I can't take things beyond that. So I'm going to just shoot for that range from the smallest to the largest. Now, as far as how many data points, well, you got to ask yourself, would having 2 data points sufficiently show a trend? Always in physics, the more data you can collect, the better. Some people spend years and years collecting data on things before they're able to publish. We're not going to get that crazy, but in the general rule of thumb for physics classes, at least 10 to 12 data points would be sufficient to show a trend that we're looking for. So I want you to think about shooting for 10 to 12 and being precise with that data as well. Estimate as carefully as you can. Some people will take averages. They'll try it a couple different times and take averages. Whatever you want to do, but you want to always be thinking, is our data valid, and have I done enough things to make sure our data is valid? To organize your work and what you'll ultimately turn into me is your lab work on just a sheet of graph paper. And so there's graph paper available for you, or you can use your own, but pretty much you see what I have on here. I have the title of the lab, I have our research question that we want to know what relationship exists between the weight and the mass for a material here on Earth. And then I also listed just some of the materials I use, like the graduated cylinder, the spring scale, buckets, water, anything else that you're using in your lab to collect your data. The last kind of intro piece that we'll have on this sheet is our data table. So you notice that I have the units along with the variable, and then I would just have my list of data sets, like with 100 grams of water, for instance, mine weighed out to be about 1.2 newtons. So go ahead and record those down. Again, you should have like 10 to 12 data points, and that's enough to get started with the lab.